So this is a good example problem for the quiz on Friday. Something like this. Oh, you get there? This is where I imagine people would make a mistake. They would factor out this to the third, make the third power instead of the negative fourth power. Factor out smaller exponent. Say again? Derivative of the inside is another negative, right? Negative 1. Okay? There, right? Same answer? This last step is a little tricky. I factored as a negative, right? And then distributed into here. Yes. Yeah. Yes. Yes, exactly. So that negative exponent, right, simply means reciprocal. So move downstairs and change the sign. Roger, anything? Any luck there? I think Kevin Johnson's teaching Calc 2 next semester as well. He's very good. Lots of examples. Very patient. On the quizzes, no, but on the test, yes. And remember, we're going to review next Wednesday. So next Wednesday, I'll do a mock test, right? You don't have to, but what I would say is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Probably not. I just think it's a little bit prettier. It's in quotes, prettier. You know how when you're writing code and you're just trying to bash it out, and you go back and look at it, and you're like, oh my god, it's so bad. Right? That habit of making it pretty to someone else. Again, it's always in quotes. Let's do another. Hey, Chris. This is our first problem, just to practice for the quiz, and I recorded it. Okay. So let's do another. Are we ready for another? Yes. Hoy, did you get there? Can I see? I'll take a look at your work. Okay. Let me get everyone started on another problem here. So this problem, I like this problem. So we're going to do a tangent line, oops, sorry, at x equals minus 4 for that product, for that function. So I need a product rule there. And a chain rule. Always do the chain. Oh, this 4, this, remember the product rule this way. You want to check the decimal? Good. Oh, good. Thanks. Yeah, give me, if you install me homework, it's subject to Friday. So we just get update the homework very, Thursday. Still means nothing. If you're passing, who cares about it? Don't worry about it. If you're failing, let's get to work. In practice for chapter 4, we're trying to get a nice looking version, in quotes, nice looking version of our derivative. Right? So, like if you got, anybody get here yet? Anybody get here yet? So once I get here, I see fractions within fractions, I get a single fraction, right? Yeah, yeah, so remember a square root function, right? It's 1 over 2 square roots, or 1 over 2 square roots, right? And then the derivative of the inside is negative 2. 1 minus 2x derivative is negative 2. Yes. Anybody get that derivative yet? Oh, I reduced my student in the, yeah, right after I did my loop, when I broke the loop down, I didn't, you don't have to do all the, yes, then get it all. Yeah. How we do? We get there? One? Yes? Jeffrey? No? Yes? You do it on Desmos? Checking on Desmos? Mister, you got the derivative? Will you get there? Candace, yes? Nice. Ariana, you okay? You got there? Nice. Uh, let's do another. Anybody need another minute? Need a minute? Okay. Sorry, Daniel. Candace, you want to get a better view, or you want to do it in two pieces? No, you got it. Sorry, Ariana did, right? Anybody need help? Anybody need money? Just making sure you can hear me. Did you get there, Nathaniel? Nice. Let's do a tough one. So I like this. I like this one um, for the quiz Friday. Let's do another tangent line. Let's say at 2 pi over 3. And let's let the function be sine squared of 2x. So what's the first, before we start this one, what's the outside function here? What is it? The square, right? So this is really kind of is thought of like this, but we write it this way just for sake of writing less. So it means, so the outside function is something squared. So what's my derivative of something squared? 2 times, right? X squared is 2x, right? So I get 2 times the sine of 2x, right? But then I'm asking, what's now the inside function? The sine function, right? So what's the derivative of the sine function? Cosine function. I'm still keeping what's in the belly of the cat in the belly of the cat, but now I'm saying, what's the derivative of what's inside? 2. And I don't know if you see this identity in green, but that's 2 sine theta cos theta. What happens to the angle is it gets doubled, right? So I get 2 sine 4x. There's my derivative. So finish it up. Get me the y value, get me the slope, get me the tangent line. x-axis change? I just go into the wrench settings, and I change my step to pi over 3. So I would get some pi over 12. Oh, because I had a 2 pi over 3, right? How we do? Close? Trig still bothering some of us? We know so what did I get for well this one is much more. But if you ever have it minus 5, 6, so it's awkward. If it's 5, then you know you get that one back. You know what I mean? Right, so if that's 28, 6, 6. But compared to that 302, that's the answer. Yes. Yes. So no anything like so 8 times 3. Right? That's all. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's like positive. It's really just like over 3. Yeah, right. Oh, but there's no 2 on top. Oh, yeah. That's the pi over 3 is what's 3. Right? Look at my derivative again. I think we got 2 sine of 4x, didn't we? For our derivative? Yeah, 2 sine of 4x. So you're going back into the original function and the slope function. I think. I don't know what you did here. But the mistake is not calculus. Good. Yes. So we know this one. Okay, then the 2 sine theta close to sine 2 theta double the angle. If we have note that product, it's sine is double the angle. So see that thing, that's 2 sine theta cos theta. It's just double the angle. Nice, you're ready for the quiz. I think the only other thing that I would put on there is possibly a quotient rule with a limit. derivative of a quotient using a limit and double check with the quotient rule, just like it was on the first test, only a little bit more complicated. Nice, here we go, new stuff. This is our last section of chapter 3. Friday, I'll do some chapter 4, very easy. It'll be just finding derivatives and critical values. We've already done that. Monday will be the start of something called the first derivative test, which again is finding derivatives, finding critical values, and then creating a sign table. You remember the sign tables in pre-cal? How horrible they were? They're easier this semester, okay? So, and then Wednesday we review, Friday we take our test, right? Of next week, yes? So I want to do section 3.7. This is our last section of the text, and we're doing derivatives of log functions. I restrict the log functions to base e. So I restrict my exponential base e. So the only function I'm dealing with is e to the x or e to the u or ln of x or ln of u, right? So our first question is, if I have y equals ln of u, right, the question is, what the hell is y prime? So what we do is we go to something we know, and that means I'm going to raise both sides base e. And what happens on the right-hand side there? I just write e and ln are inverse functions, right? So they cancel each other out, so I just get the function u. Everybody okay there? You remember that from pre-cal? And so now I want to differentiate both sides, d dx. And on the left, what do I get? E to the y times, nice, y prime. And on the right-hand side, I just get u prime. So if I solve this for y prime, I get u prime over e to the y. But what is e to the y? Do you see it here again? E to the y was just u. So look how simple this derivative becomes. And so you're writing down this formula. If y equals the ln of u, y prime is u prime over u. And so this, once again, just like we had with the arc tangent and the arc sine and the arc cosine, I gave you a formula. What you had to say, oh, find u prime, find u squared. Same thing here, only easier. Find u prime. Plug it in. Plug and chug. You don't have to think about these. You have to accept, you have to memorize, you have to practice. So when you're doing these derivatives using the natural log, and that's how I'll say it. Find the following derivative using a natural log, or the natural log will already be there, or I'll say the ln trick. Okay, and you'll see all of those three kind of problems today. So there's not much here. Just like in the arctan and the arcsine, find u prime, find u squared, plug it in. Same thing here. Find u prime, plug it in. Really, really simple. Let's start with y equals ln of the ln of x. So, right, we want to find y prime, yes? So what's the inside? What's the inside? ln. So I need the ln, and I need what's inside downstairs, u prime over u. What's the derivative of the inside? One over. Right, so if my inside, I'll call it w, is ln of x, w prime is derivative of x is 1, inside is x. So here it is, 1 over x divided by ln of x, or y prime is 1 over x ln of x, or what? Ln of x to what power? What I hear? Square. X. Remember that outside coefficient is a power in the argument of ln. This answer's fine. Let's do another one. So I am looking at section 3.7. I think I gave you suggested problems in 3.7. Can someone double check that for me? This is 3.7 number 5. I didn't, no? I gave 3.6, so I like up to, I think 50, 55. And of course we got the answers, right? We were looking at the answers earlier today. There's 3.7. I guess I like up to 67, but it's fine. It doesn't matter. Every problem I like. So here's 3.7 number 5. Y equals the ln of sine squared x. So remember what we have memorized. Y equals the ln of u gives me y prime is u prime over u. It's that simple. Don't overthink it. We as humans, when things are so simple, we start to overthink it. One of my favorite Confucius sayings is, draw a snake, add legs. It means don't overdo it. This guy was in a snake drawing competition, and he was done so early, and he had the most beautiful snake ever drawn, but he was done so early, he figured, oh, I might as well add legs to it. And then he lost, right? Draw a snake, add legs, right? Kill tree, pass class, okay? So what's my inside? Okay, so that's going to be my denominator, right? And the derivative of the inside, we already did today, is 2 times the sine of x times another cos of x. Right? Agreed? We did that one today already, right? Bring down the 2, keep sines of x inside the box, then the derivative of sine is a cosine, right? So what do I get here? Looks like I get 2 times cos of x over sine of x, which is 2 times the cotangent of x. Easy, right? Very, very easy. You don't need to overthink these. You don't need to overthink the arc inverse trigs, but you have to practice them. You have to go practice them. You can't just say you get it. You have to get in there and get dirty. Get that pencil and paper or whatever you're using to write with, right? And get some work done. Let's do another one. This is 13. And I have y equals the ln of x plus square roots of x squared minus 1. And this is a classic example of, do you have the answer the book has, right? So when you're doing these, have the answers ready, have the answers open, and then look at your answer. If your answer is not right, either you did something wrong with your calculus, most likely it's something you didn't do with your algebra, okay? So, and then you got to get creative. I mean, are you someone that says math is not creative at all? I'm sure some of you are thinking like that, but then you've got to take all your algebra skills and try and apply them. Okay, so this is a good example. What's the inside? Yep, nothing to think about much at all there. What's the derivative of the inside? 1 plus 1 over 2 square roots, keep the cat in the bag, times another derivative of the inside, 2x. Right? X squared minus 1 derivative is 2x, yes? This one is not even close to what the book answer is. Watch the book answer here. This is, what did I say it was? Number 13. So 3.7, number 13. Look at the answer. Are you kidding me? Right? So I know my calculus is right. I got to do some algebra. So what do you think? What are you thinking? Say again? Yeah. LCD would work. What else would work? Oh, X. Yes, sorry. Thank you. So the other thing that would work here is the conjugate. So I'm going to do conjugate first, just because I feel like it. So obviously I'm doing the conjugate of the downstairs, right? And I'm going to leave the upstairs alone. And then downstairs it simplifies quite nicely, right? I get what? X squared minus the quantity of x squared minus 1. Oh, that's nice. That's just 1. Right? Do you agree? So on this one, I don't know what to do. I could try and clear fractions now, or I could just FOIL. So I'm gonna FOIL. So I get something now that can finally do my LCD. And I'm not saying I had to do it this way, right? And I know I already practiced this problem. When I started with the LCD, it got messier quicker. So then I said, well, maybe I should try conjugate first. And this is the same process you all have to go through. No, I can't teach you every little trick. It's impossible. You have to get in there and discover some of them, right? Get things wrong, figure them out, do a lot of problems. Eventually, you'll have the skills. So now I'm doing an LCD. I want to go back to the, is this okay? We okay here? I mean, you clearly see I'm not thinking much, right? Figuring out u prime, plugging in. And then the algebra happens. After I get u prime, calculus is finished. Calculus is easy. The algebra is not. But you have to get in there and practice. Driving is easy. Parallel parking is not. Anyone agree with me on that? All right, here we go. Another problem. I want to go back to the first problem we did today, and I'm going to use something I call the ln trick. Or I'll say to you, find the derivative by first taking the ln of both sides. So my first problem again, I forget already. There it is. So my first problem I did today was y equals, and I want to find y prime, y equals 5 minus x to the negative 3 times 1 minus 2x quantity squared. Okay. So what I'm going to ask you to do is find me y prime, but take the ln first of both sides, or ln trick, okay? So we take the ln of y, and that should equal the ln of this whole product. But if you remember, logs are exponents. The answer to a log question is an exponent. And what I'm saying is, if I'm multiplying like bases, I'm adding exponents. So remember that property from pre-cal, right? ln of AB is ln of A plus ln of B, right? Remember that? This is me multiplying like bases. What I'm actually doing is adding exponents. So I get here the ln of that first factor plus the ln of the second factor. Is that ringing a bell to anybody? Reminds me of one of my favorite jokes, but it's way too long to tell. But anyway, there was this, you know about the Hunchback of Notre Dame? He would ring the bell to warn the people. Well, this guy, they had no rope, so the hunchback would just run at the bell and hit it with his head, right? And one day he ran too fast and glanced off the bell and fell off the tower and died. And people gathered around and they said, "Oh my God, what's his name?" And I don't know, but his face sure rings a bell. Now, what else do we have? ln of a to the m, that power comes down, right? So you can see here in my problem, I can bring down that power of negative 3 and bring down that power of 2. And now when I take my derivative, it's so much nicer. Okay, ready? Don't let me go too fast. Everybody with me? His face sure rings a bell. Here we go. What's the derivative of ln of y? Y prime over y, right? The inside derivative over the inside. What's the derivative of ln of 5 minus x? The negative 3 comes for the ride, right? So what's the derivative of ln of 5 minus x? Negative 1 over 5 minus x. What's the derivative of ln of 1 minus 2x? Negative 2 over 1 minus 2x. It's that simple. Derivative of ln functions is that simple. Derivative of the inside over the inside. You don't have to, what we've done is we said, hey, you already know the chain rule now. So now all you have to do is see this pattern. You don't have to think about the chain rule. So we can simplify this a little bit. And I'll do that with y prime equals 3y over 5 minus x minus 4y over 1 minus 2x, right? You see, I'm just distributing. Remember, I'm solving for y prime. And I'm going to put back in that value of y. And you can see I'm back to the original problem as a product rule, kind of. You see it? You see I'm back to the factoring piece or the LCD piece. I don't have to finish this because it's the same as the first problem we did today. If you want me to finish it, I will. Do you want to at least see what my first thought would be here? Yeah, my first thought would be to cancel my denominators, right? So I know this one is going to go away, this one's going to go away, and then I'm exactly at the factoring part. So I get 3 times 5 minus x to the negative 4 times 1 minus 2x quantity squared minus 4 times 5 minus x to the negative 3, times 1 minus 2x. So you see I'm right exactly to that product loop now. Is that making sense? Jack? Yeah? Nice. You have to do problems. That's what it takes.